decision, opinion, will you take the decision? Will you go for MBA if your father say that after BTech, if you'll do MBA, that will be good for you? Yes. No one is saying anything. You will seriously just agree with your father's decision. Okay, I'll go for MBA after BTech. Have I joined the wrong session? No. Just give me a minute. I hope I have joined the correct session because no one is answering here.
I guess.
I think it's the right session I have joined.
Yes.
Kindly mute yourself. Those who's speaking on call, okay, it's on call. Now you will take different people's opinion to take a final decision. Okay, right. Similarly, when you have data set, okay, you give it to different algorithms. Okay, because if you'll give only to one algorithm, okay, this data set I have, if I'll give only to one algorithm, okay, one model will be created, and based on that model, if I'll take the decision, that will be my weak decision. Okay, that will be my weak decision. Okay, based on just one algorithm, I have taken the decision. So what ensemble methods give you? It gives you the option that give the data set to different algorithm. Okay, prepare different models, train different models, and once and then come up. Then if I come up with a new row, okay, testing record. Okay, I give it to these different models, these trained model, and I'll ask these models to give me the output. Okay, for this new record, one will say, suppose answer is yes or no. Okay, or suppose you are selecting like wear black dress or blue dress for tomorrow's D-Day. Means for maybe there's a good event where you want to go. Okay, so this model is giving you the answer that wear black dress. Okay, this model is giving you the answer wear blue dress. Oh, both start with BL, blue. Okay, and this one says black. Okay, so you will go with the maximum one. This is the option it gives. Okay, now these are the different algorithms. Okay, A1 algorithm is there, A2 algorithm is there, and A3 algorithm is there. And don't think like you can choose only 3 algorithm. You can have more than one algorithm, up to you how many algorithms you want to use. And based on that, different models models will be trained. Okay, now these things are ready. Now tell me, if I use same algorithm, like if I use A1 here, A1 here, and A1 here, same algorithm, and I'm giving the data set to this model, will it not give me the same answer every time? I have same algorithm. I have A1 here, A1 here, and A1 here. I'm giving the data set to these models. Okay, to these algorithm, and I'm preparing a model. If I give a new record to these model, will it not give me the same answer? If A1 is giving me black, this one is also give me black, and this one is also give me black. Yes or no? Will all these algorithm will give me the same answer or not?
Yes, ma'am.
Now, if you want to use the same algorithm, then to have randomization, you can do one thing. You can randomize your data. The data set which you are giving to the model, you can bring randomization there. Okay, instead of giving the complete data set, give only some selected rows. Okay, means some rows will be selected from this data set, and that will be given to your algorithm one if they have the same algorithm. Okay, if they have different algorithm, no problem, but if you have same 2 means data 1 will be goes to A1, data 2 will be goes to A2. This A1 only. Okay, algorithm is same, and data 3 is gone to the this model. Okay, then 3 model, those the models which will be prepared now, that will be different. Model 1, model 2, model 3. Otherwise, they will give you the same output. Okay, now how the data is selected? Some random rows will be selected, and it will be like if you have learned about probability, there was always a question like you have a container where red, blue, and white ball is there. Okay, and you have to pick up a ball. You have to pick a ball and then tell the color. Okay, suppose it's a blue color. Then another thing is it is with replacement, that put that ball which you have just picked again into that container, mix that container, mix the balls, and then again pick up a ball. So there are chances that you can pick the same ball. Similarly here we are picking the rows with replacement. There is randomly we are picking some rows and we are picking them with replacement. Okay, it is not like one ball which you have picked, you have thrown it out. No, that ball you have again put down onto that container, into that container, and then you are again randomly picking some ball. So there are chances that that ball could be the same ball which you have picked before. Okay, and another thing, there could be some balls which are never picked, right? So here we have the same scenario, that the rows which you are picking, those rows could be same in the same algorithm. The rows could be repeated. Okay, suppose one row is came over here, the same row came over here as well. Okay, the same row came here twice. Okay, this could happen. So there never which was never picked by any of the model. Okay, so there could be chances when you are picking the rows. Now, after getting the answer, like you will give the testing record and ask this model to give me the output. After getting the output, those output will be aggregated in a, that will become your predicted model, the optimal predicted model, and that will be called as a strong model. So it will give you the output based on the maximum one. Like if you have black 2 times and blue 1 time, so you will choose black, you will go with black. So these learners are known as the base learner, and this one will be known as the strong, you can say strong model. These are weak model, this one is strong model. Okay, now this part, the data which you are giving, let me come over here. Okay, see, this we have discussed. Now advanced ensemble techniques we were discussing, in which we have discussed bagging. Okay, bagging is consist of 2 words. One is bootstrapping and another is aggregation. So the drawing which I have done over here. So this one is your bootstrapping. You are randomly giving data with replacement to the models. So this, and you are training the models based on these data set. This is bootstrapping. Aggregation is when you are getting the result from different models, you are aggregating, and based on the maximum or the averaging, you are giving the output. Okay, so this one is aggregation, and the randomly selection of data with replacement is bootstrapping. Okay. Now, in bagging, we have an example of random forest. In random forest, we have 2 type of randomization. Okay, what is that? I have discussed it yesterday. So today I'm giving you a small intro of bagging. Okay, so of random forest. So let's suppose I have this data set. Okay, this is my main data set. I'll give it to my different models. Different decision tree. When you talk about random forest, we talk about decision tree. Okay, so all these algorithms are the decision tree algorithm. Now, see, one randomization we have done, that we have given different data with replacement, means randomly selected data with replacement to these models. So it will be D1, it will be D2, it will be D3. D3 will be D2. Okay, and so on till Dn. Okay. Now, this is my model 1, model 2, model 3, and model n. Okay. Now, another randomization is, remember when we have seen the decision tree numerical. There, when we were finding the entropy, So when we were finding entropy, first we have calculated it for the target variable, play golf, remember? And then we have calculated the entropy for every attribute present in our data set. After finding entropy, we have calculated information gain for every attribute, right? But here, when we talk about random forest, first thing, randomly data is selected with replacement. Another thing is we will pick attributes randomly. Suppose this is my data set. I have 3 columns over here, A, B, C. And one is my target variable. Okay. So what I'll do, I will randomly select some attribute. Okay, this for entropy for this, obviously I'll calculate, but entropy for these, what attribute should I select? Earlier for decision tree, I was selecting all the attribute and then I was calculating entropy for every attribute and information gain as well. Okay, here I will randomly select some attribute. For example, I select this AB. Okay, so what I'll do, I'll find the entropy and information gain of these attributes whose information gain is higher will become the root node. Okay, then for the next level, I have created root node. Okay, then for the next level, what I'll do, I'll again randomly select the attribute. Okay, one which is already selected, I'll not take that into consideration. The remaining attribute, I will select some random attribute. I'll find its entropy and information gain, and based on that, I will make the decision node. Okay, and so on. So for one decision tree, I have done that. For another as well, I'll create decision tree. And for every other model, I'll do the same thing. So here we have randomization at 2 places. One is in selection of data, another is in selection of attributes while creating decision tree. Okay. So two types of two different randomization is there when we talk about random forest. Now here what we do at last we will give a test record to every model. Okay, sorry, my drawing is not that good. So I'll give that test record to every model and I'll ask them to predict the output. They will predict the output, and based on the output, the maximum vote whichever is there means if I have here yes, here also yes, here also yes, and here I have no. So I'll go with the yes. Okay. So this is the step which overall ensemble method have. Okay. But I hope decision trees, this random forest is clear. We will see its implementation now. I hope the theory part is clear to everyone.
Yes, ma'am, clear.
Okay, good. Let's see the last slide I'm discussing for random forest, and then we will see its implementation. How it works. First, we select K data points, okay, from the training set. Another thing, we will create a decision tree for the selected data points. Then we will tell how many decision tree we want. In random forest, different decision tree, several decision tree are created that we have to tell. If you want 10, 20, 15, how many? That you need to tell. So as the number of decision tree increases, your decision will become strong. But you cannot have like hundreds or means according to your data set, it depends. But you cannot have too many decision tree, because if you have too many decision tree, your algorithm will be slow. Okay, so you have to take care of that as well. Then you have to repeat your step 1 and 2, and then you can have a test record. This new data points means you can have test record, and for that you can predict the output. Okay. This is the these are some of the things we are going to use while implementation, that we are going to from sklearn ensemble, we are going to import random forest classifier. Okay, then we will create our classifier or prepare our model. Okay, using that random forest classifier, where we can mention the number of forest, number of estimators, number of not forest, number of trees we can mention. By default, its value is 10 and you can change it. If you will not mention anything, it will take a value 10. Another thing, yesterday I have told you, I hope you have remembered that this criteria we have mentioned entropy here. If we do not have entropy, what else we can mention over here? Decision tree we can solve by two methods. One is entropy, another is Gini index. Right? So you can go with the Gini index as well. Then you have to train your model. We have stored our model or classifier into the classifier variable. So while we are training, we have to write it like this: classifier dot fit, because in classifier we have stored all the you can say all the variables, all the attribute values which will be requiring further. Okay, then we will train our model. X train and Y train we will pass. Okay. Let's quickly see its implementation. Okay. So I hope my screen is visible to everyone. Okay.
Yes,
So
ma'am. It visible.
okay. We have a data set, bank note authentication. You can find the same data set online as well. Okay. Here we have some features like variance, skewness, kurtosis, entropy. Okay, so these are the features given, and based on that, a class is there which says that the banknote is authenticated or not. So 0 means not authenticated and 1 means authenticated. Okay. So this is the data set we have. What we are going to do, we are going to generate a random forest based on that. Okay, and we will tell how accurately for new data set it is giving you the answer. So if for means if a new record is given, okay, whether your trained data is being whether your trained model is being able to identify, is being able to give you the correct Basically, banknote which you have given is authenticated or not. So let's just see its code. So firstly, we have imported some of the libraries like pandas, because you need to read your library, read your file, you need to do the pre-processing steps. This is the reason we have imported pandas here. Okay, sklearn, because in sklearn already these algorithm is being implemented. Okay, this random forest, you need to do the train test split that is given in sklearn. You need to do the run, you need to use any classifier that is being given in your sklearn. You want to create confusion matrix or accuracy score, that is also given in sklearn. This is the reason we are importing all those things. Okay. So let's just execute these commands. Okay, successfully executed. Now what we are going to do, we are going to read our data set. Okay, so the file which I have shared with you, weather file, that is the Excel file. Okay, so if you are reading that file, just remember, instead of CSV, write Excel there, and instead of CSV over here, write the extension X, SLX, whatever extension is given, write that. Okay, since the file which currently I have, banknote authentication, as a CSV file, this is the reason I'm writing here pd.read_CSV, then the file name, then its extension. I have to give here a complete path. If I'm not giving a complete path, I can choose the directory from here. Okay, so it's on my desktop with a classification folder. Okay, and select folder. Okay, now let's just run this command. So my data set is read in banknote, which is banknote authentication. Okay, let me just increase its size. Okay. After that, if you want to see the length of the data set, okay. So we are analyzing our data, how many rows, columns are there. Okay, so length will give you basically the number of rows it has. Okay, so let's just check it. So we have 1372 rows. Okay. Now tell me quickly what will this function will give you, dataset.hit. We have seen this so many times.
First five rows.
Right. So it is giving me the first 5 rows. Now dataset.shape. Length has given me the number of rows. What dataset.shape will give me?
Number of rows and number of columns.
Yes. The shape of the matrix. So we have 5 columns. Okay. Now dataset.info. See, column name, number of non-null rows present in this. Okay. And it is also telling that it's non-null plus its data type. Okay, so all the attributes are float type and the class is of integer type. Okay. Now see here also you can see that we have total 1372 rows, and all the rows here you'll see 1372 rows, all these are non-null. But still, if there are too many attributes, okay, so if you don't go with this information part, what you can do, you can use this method. IsAny will give you number of null values present. Okay, if there is any null value, it will return true or false. Okay, what we are doing, we are writing after that dot sum, means the number of null values, sum of the null values. Okay, so if there is any null value, it will give it sum. Okay, so there are 0 null values there. We have already seen that using information, but if you want to see, like if you don't want to see all those numbers, these big numbers, if you want to see that if there is any null value, give it sum. So it will, for every variable, for every attribute, it will check, and then from the attribute it will count. See, suppose if it have some null values, it will count that and will tell you that there are 5 null values, there are 2 null values, like that. Okay, so here we have 0 null values. Now describe if you want to have some statistical information, okay, like count, mean, standard deviation, all those things, if you want to know, you can use this describe function. If you have learned Python basic, there you must have seen this describe feature. Okay, describe function. Now, another thing, if you have any duplicate entry, okay, if you want to see duplicate entry, so we can write dataset dot duplicated. Okay, so let's just write this. Let's just execute this. Let me show you the complete command. So it is giving you the duplicated value size, means how many rows are duplicated. Okay, so let's just execute this. And another one is giving you which rows are duplicated. Okay. Okay, so it has given you the duplicated values. Now what you are going to do, the values which are duplicated. So keep the first one, means first row, keep it. If another time that row is duplicated, just drop that one. Okay, means drop the duplicate except the first row. Okay, so if you'll keep the first one, then there will be no duplication. Okay, that we are going to do. Let me just execute only this one, and then we will see its shape. Let's run this now. See its shape. Earlier it was 1372 or 1327, something like that. Now, no. Just see its shape. It was 1372. Okay. Now it is 1348. So the duplicate rows are deleted now. Make sure whenever you are dealing with any data set, you check the null values, you remove the duplicate values. Okay. These are the steps of pre-processing. You need to pre-process your data. After reading the data set, you need to pre-process your data set, right? So checking these null values, handling these null values, handling duplicate rows, these are the steps of pre-processing. Okay. Now, after pre-processing, we will split our data set. Okay. I hope I have executed this. Yes. Okay. Now we need to split our data set into the testing and the training set. Okay. So what we are going to do in our this y is our target variable. Okay. So in y we are storing class. Okay. If you remember this is the class attribute. Where it is. See this one. This is our target variable. So this we are going to store in y, and these A, B, C, D column like variance, skewness, kurtosis, entropy, these we are going to store in x. Okay, remember x and y we create. X and y are not, you can say these are not the keywords. It's up to you what variable you take, but generally we take x for these attributes, those features, and y for the target variable. So the class we are storing in y, and in x we are storing all the variable and we are dropping class from there. Okay, so we have taken all the attributes and dropped the class from it. Now our x and y is ready. Let's just run this. Splitting is done. Okay. If you want to see the variable over here, variable explorer, go to the x. See here, all the attributes are there except the class attribute. And if you'll go in the y, only class attribute is there. Okay, this division we have made. Now we are going to split our data set into test and train. We have divided x and y. Now we are going to divide our train data set and test data set. So the values you have to mention in order. X train, X test, Y train, Y test. 4 variables we have created. In these variables, we need to store the data. In X train data set should be there. X values of train data set should be there, and X test, X values of test data set should be there. Similarly, in Y train and Y test. Okay, so we are using train test split from sklearn. Now we are mentioning X here. So the X values, those will be splitted. and those splitted value will go in X-train and X-test. Now in Y, values will be splitted correspondingly, which are the corresponding values to X, and those values will be given to Y-train and Y-test. Then test size we have mentioned, and random state. If you will not mention random state, it will pick the randomly only, pick the data randomly only. Okay. Now let's just run this command as well. Okay. Successfully executed. Now let's just prepare the classifier that we have seen in the PPT as well. This is our classifier, random forest classifier. The value the classifier we are storing in CLF variable, and a number of jobs we are mentioning, and criteria we are mentioning. This number of job is not the the estimator. Okay, it's different. Just give me a minute. We have done this X-train and X-test. No, we have our data set which we have split it in X-train, X-test, Y-train, and Y-test. After that, we need to train our model. Okay, splitting we have done, and then we have to train our model. Sorry, train our model. To train our model, first we will set the classifier. Okay, and which value we are storing in CLF. Now, since we are using we are implementing it using random forest, we are using random forest classifier. Then here, if you here firstly see there are it is not like that you have only two attributes over here or two arguments over here. Okay, you can have several arguments in this classifier, and these are optional if you want to mention. One is like estimator, which we have seen in the PPT. If you don't mention it, it will by default take 10 decision tree. Okay. Criteria, we have discussed that criteria for decision tree we are mentioning. This is number of jobs we are mentioning. So parallelly, how many parallelly it should do the fitting, means training and the prediction. So both these things it can do parallelly that we mentioned. So it's some default value is also there that you can go to the sklearn and you can study about that. Then after fitting, after left, and then we will fit our model. Basically, we train our model. And for training, we pass both the values, X train and Y train. Okay. And for predicting, we pass only Y test. Okay. Test. Okay, Y test, Y test needs to be predicted. We pass only X test. So for training, we have passed these two values. Now we will predict our value. Predict for what? For X underscore test. Okay. And since our model is trained for CLF, okay, so we will write CLF dot predict X test. That value we can store or you can directly print it. Up to you. Okay. Now, after storing it, we are printing it. We are printing that variable, the prediction value. Let's just run this. Let's just train our model first. Okay, our model is trained. Now let's just test these values. These are the predicted outcome. Okay. Now, if you want to see it in a confusion matrix or an accuracy score, let's just first check the accuracy score. Okay. So accuracy score, in when you are printing it, you have to pass Y test. Y test is your actual value. Prediction is your predicted value. Okay. So basically both these values are compared and then it will give you the accuracy. So let's just run this first. So accuracy we are getting 0.99 means 99.75%. Okay. Let's just see the confusion matrix as well. So we are getting this matrix 212, 0, 1, 192. I hope you have remembered what is confusion matrix, what are the values you can calculate from confusion matrix, and what are the values put in, why we have 4 values inside it. Clear, everyone? Now what I'll do, I'll share this code and this data set as well with you. And since you have not solved the previous problem, now I'll not give you any new problem. Just try with this, and if you want to try, you can try with new data sets. You can go on to the Kaggle, you can search new data set and try the random forest for those algorithms. Okay. Now if you have any doubt, please ask. Then I'll continue with your boosting. Okay. Boosting is left. I'll continue with that and then we'll wind up the session. Any doubt, anyone? Okay, Rajnanti. Okay. So I think we have enough 12 minutes. I can discuss boosting. We will not see the implementation, Ashish. We will only see its theory part. Okay. If you want to try, you can try. Okay. You can try later on, and if you face any difficulty, you can ask your doubt. Okay. Give me 2 minutes. Okay. So boosting is where the algorithm learns with errors, you can say. Okay. So example for this is AdaBoost. You can implement AdaBoost and adaptive boosting basically it is. Okay. You can implement, you can have the data set from Kaggle or any other site and you can try implementing AdaBoost. Let's see how boosting works. Okay. So I don't have actually. Okay, so let's suppose this is our data set, main data set. where all the rows are given. And here we have different models. So it is a sequential type of thing. Okay. And there are so on. Different models or different algorithms will be there. Okay. So what will happen first? What we will make a probability column like this. Okay. So, and we will give to every row, we will give the some probability, and every probability will be same. Let's suppose one probability we are giving to every row and so on. Okay. Now, what does this mean? This means is every row is equally probable to get selected in this model for this algorithm. Okay. So, since every row is equally probable, some rows will be selected, okay, at one time. Suppose 1, 3, 5, 7. Okay, these 4 rows are selected. I don't know why always these number came into my mind. 1, 3, 5, 7. These rows are selected. Okay, for my model 1. Now, this model will give maybe for this it will give me right answer. For this it will give me right answer. But for 7 and 5 it gives me the wrong answer. Okay, then what we do over here in the next term, we will increase its probability. Row number 5 and row number 7 probability we will increase. Okay, it is not like 1, 1, 1 because after 1 what you can increase? Maximum probability is 1. Okay, it is something like 0 point something and every row is equally probable. Okay, now for the next term, okay, it was in first go. For the next go, okay, the probability for row number 5 and row number 7 will be increased. So what will happen now? These will become more probable to get selected in your next model. Okay. So there are chances that 5 and 7 will be selected in your next model. Apart from that, some other rows will be selected. Suppose we are selecting 4 rows. Okay. So there are more chances that 5 and 7 will be selected. Apart from that, some other rows will be selected. Suppose 5 is selected, but 7 is not. Okay. Apart from that, okay, let's suppose 1 is selected again. Then we have selected 10. Okay. And we have selected 2 as well. Okay. So what will happen now? This model will also try to give the output. Okay. So let's suppose it will give you the output for 10. It gives you the wrong. Matlab means for row number 10, it is giving you the wrong output, and for row number 1 as well. And for it is not like for every time it will give you the wrong output for 2 rows. I just accidentally take the 2 rows which are incorrect. Okay. Now what will happen for the next go? The probability for these rows will be increased. Okay. So there are higher chances that these rows will be selected in your next model and so on. There will be sequence. Okay. Every time this model will give you some output, this model will give you some output, this model will give you some output and so on. And what we are doing every time any model give wrong answer for particular row, we increase its probability. Okay, so what will happen? The chances of the selection of rows of the whose probability is greater is more in the next model. So what will happen when you give any new test set? Okay, so suppose we have given these two are 4 models. We have given our data set to 4 models. They have given us some output. Now what we will do? We will come up with a new row and we will ask these models about the output. Okay. They will give you some output, and based on the maximum one, we will take the final decision. Okay, this will be a strong model based on the output of these models. So this is the sequential one. AdaBoost is the example of boosting. You can download the data set from Kaggle and you can implement. Okay, you can see that what is the suitable data set for your AdaBoost algorithm. You can download that data set and try to implement algorithm. Okay, try to solve that problem using AdaBoost. Okay. So this is basically boosting. Okay, this is one of the ensembling method. One We have studied in detail which one is that was bagging and this one is boosting. Okay, try that. If you face any difficulty, do let me know. Okay. Now, if anyone have any doubt, please ask, because tomorrow we will start with the clustering. We will have k-means. We will implement k-means. Okay, I'll give you a detailed description of k-means and clustering, and then we will implement that as well. So maybe by Friday, your all the lectures will be completed, and then assigned any guide. I'll share the list with you in group in mail. Okay. Once your lectures get over. Any doubt, anyone?
Ma'am, not done. But can you please send the PPT for today's?
Yes, I will kindly share today's recording along with presentation. Okay, I'll share the PPT. I'll share the recording with you, Shrikant. Okay, and I will share the data set and program as well. Yes, there are chances that some of the rows are never selected or never get selected. But when there is a first step, at the first step, the probability of selecting all the rows will be same. Okay. But still there are chances that there could be some rows which are never get selected. Any other doubt? Okay, then I'll share the study material by evening. Okay, and try to implement these algorithms. And tomorrow we'll start with clustering. Thank you. Bye-bye.